Now more than ever, Lowe's knows you don't just want a low price, you want the lowest price. And with our lowest price guarantee, you can count on us for competitive prices on all your home improvement projects. If you find a qualifying lower price somewhere else on the same item, we'll match it. Lowe's, we help, you save. Price match applies to same item. Current price at qualifying retailers. Exclusions and terms apply. Learn how we'll match price at lowes.com/lowest price guarantee.
Career changers, including veterans and active duty service members. Your transition starts here. Go from GI to IT in a matter of months. Become a certified cyber warrior with training at My Computer Career. Cybersecurity specialists are in high demand, offering IT pros great opportunities and a rewarding lifestyle while protecting our people, liberty, and treasured institutions from cyber threats. Deploy your career in IT today. Learn more at mycomputercareer.edu/CWP. SkillBridge and other VA benefits are available to those who qualify.
This is SpaceTime, Series 28, Episode 69, for broadcast on the 9th of June 2025. Coming up on SpaceTime, doubt cast on the impending galactic collision between the Milky Way and Andromeda. A new study explains why seismic waves suddenly accelerate deep inside the Earth. And a new technique discovers 5 new embryonic planets. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study is casting doubt on the timing of the long-expected collision between the Milky Way and the Andromeda Galaxy M31. The findings, reported in the journal Nature Astronomy, are based on new data from NASA's Hubble Space Telescope and the European Space Agency's Gaia spacecraft. Astronomers have used the new observations to create fresh computer simulations showing how these two large galaxies will evolve over the next 10 billion years. The two galaxies, which are the largest in the local galactic group, are currently located some 2 million light-years away from each other and are moving towards a merger at a speed of about 100 kilometres per second. A collision would be devastating for the overall structure of both spiral galaxies. Although the stars themselves wouldn't collide, there's plenty of space between them, the beautiful spiral arms of the galaxies as a whole would cease to exist, replaced by a spheroidal pile of stars known as an elliptical galaxy. The authors of the new study ran 100,000 simulations of both galaxies based on the new observational data, and for the first time this included the effects of the Milky Way's most massive satellite galaxy, the Large Magellanic Cloud. As a result, they found only a 2% probability that the galaxies will collide sometime over the next 3.7 to 5 billion years. That's contrary to the previous belief that a galactic collision and the demise of the Milky Way as an independent body was a certainty within that time frame. In just over half of the simulated scenarios, the Milky Way and Andromeda experience at least one close encounter before they lose enough orbital energy to eventually collide and merge. But that's now likely to happen somewhere between 8 and 10 billion years from now, and on that timescale, our Sun will have already dropped off the main sequence, having fused all its hydrogen core into helium, expanded out to become a red giant, puffed off its outer layers, and ended up as a white dwarf. Now, in most of the computer simulation scenarios about the galactic collision between Andromeda and the Milky Way, it seems they'll pass at such large distances from each other that they'll continue to evolve largely unperturbed for a very long period of time. Although the new research challenges the previously accepted fate of the Milky Way, the study's authors admit it's still difficult to make very precise predictions. The study's lead author, Till Sawala from the University of Helsinki, emphasised that the new conclusions don't imply a mistake in early calculations, rather that the authors were able to include more variables within their simulations. Earlier calculations focused on the interaction between the Milky Way, Andromeda, and a third galaxy, the Triangulum. They're the 3 largest members of our local galactic group. Although the Large Magellanic Cloud only has about 15% the mass of the Milky Way, its gravitational pull directed perpendicular to the orbit of Andromeda nevertheless would perturb the Milky Way's motion sufficiently to significantly reduce the chance of a merger with Andromeda. Sawala says while earlier studies only considered the most likely value for each variable, running many thousands of simulations has allowed the authors to account for all the observable uncertainties. Now, these new results are significant for the fate of our galaxy. But this new uncertainty about the future of the Milky Way and Andromeda may not last for long. The authors are already looking ahead towards new research, further scenarios, and even more data becoming available. You see, the Gaia Space Telescope will soon be delivering more precise measurements of some of the most crucial variables within the galaxies, including the transverse motion of Andromeda, which is difficult to measure directly. This is SpaceTime. Still to come, why seismic waves deep inside the Earth suddenly accelerate, and the discovery of 5 new embryonic planets using a new technique. All that and more still to come on SpaceTime. A new study has provided fresh clues about the mysterious behaviour of seismic waves as they traverse a weird zone deep inside the Earth. A report in the journal Communications, Earth and Environment has found that the crystal structure of minerals deep in the planet's D layer is accelerating the movement of seismic waves. The D layer is located near the Earth's core-mantle boundary, some 2,700 to 3,000 kilometres beneath the planet's crust. This region consists of a mixture of molten rock flowing sort of like honey or molasses, rather than being either liquid, like lava, or brittle, like solid rock. For more than 50 years, scientists have wondered why seismic waves suddenly behave differently in this D layer, with their speed accelerating as if they were travelling through a different material. Then in 2004, one of the study's authors, Motohiko Murakami from ETH Zurich, discovered that the mineral perovskite, which dominates the D layer, transforms under extreme pressures and temperatures into a new mineral, a different mineral, which they've named post-perovskite. Scientists assumed that it was this change which was explaining the strange acceleration of the seismic waves. But then in 2007, Murakami and colleagues found evidence that the phase change of the perovskite alone simply wasn't enough to accelerate the seismic waves. Now, using new computer models, they've discovered that depending on the direction in which the post-perovskite crystals are pointing, the hardness of the mineral changes. It turns out the seismic waves are accelerated only when the crystals of the mineral point in the same direction. Now, the big question then becomes, what makes these crystals line up? Well, it seems the answer is solid mantle rock is flowing horizontally along the lower edge of the Earth's mantle. Researchers have long suspected that this movement, a sort of convection like boiling water, must exist, but they've never been able to prove it directly. The new computer simulations developed by Murakami and colleagues have now demonstrated, at least experimentally, that mantle convection of solid rock is real, and it's occurring at the boundary between the Earth's molten liquid outer core and the mantle above. The discovery not only solves the mystery of the D layer, but also opens a new window into the dynamics in the depths of the Earth. This is SpaceTime. Still to come, astronomers have developed a new technique which has allowed them to identify embryonic planets, and later in the science report, a new study warns that artificial intelligence is now so smart it's refusing to turn itself off even when instructed to do so. Looks like Skynet, if not the Terminator, may well have arrived. All that and more still to come on SpaceTime. This episode of SpaceTime is brought to you by NordVPN, SpaceTime's official VPN service. Let's face it, these days your online privacy is more important than ever. Whether you're streaming science documentaries, reading the latest research, or exploring deep space images, you don't want your data to be tracked or your location exposed. With NordVPN, one click is all it takes to secure your internet connection. It encrypts your data, hides your IP address, and keeps your activities safe from prying eyes, whether you're at home, work, or connected to a public Wi-Fi. And here's where it gets really good. As a SpaceTime listener, we have an exclusive offer for you. 74% off a NordVPN plan, plus 4 extra months for free. That's right, a huge 74% discount, plus 4 bonus months, just for being a SpaceTime listener. All you need to do is head over to nordvpn.com/StuartGary. That's nordvpn.com/StuartGary. Not only does NordVPN protect your data, but it gives you access to content from right around the world. If you want to watch a science series that's only available in another country, no problem. Just switch your virtual location and unlock it instantly. And of course, the whole thing is risk-free with a 30-day money-back guarantee. So you've got nothing to lose and your online freedom to gain. So, Protect your digital life, support SpaceTime, and grab our exclusive offer now at nordvpn.com/StuartGary. That's nordvpn.com/StuartGary. And now, it's back to our show. Astronomers have developed a new technique which is allowing them to identify embryonic exoplanets at a far earlier stage of their development than ever before. Exoplanets are planets orbiting stars other than the Sun. Astronomers have so far discovered well over 5,000 exoplanets, usually by either the transit method, in which some of the light from a host star is briefly blocked out by an eclipsing planet, or by the wobble method, in which the host star is being affected by the gravitational pull of an orbiting planet, resulting in a slight Doppler shift in the star's spectra. Now, a report in the astrophysical journal Letters claims the new technique, which uses ALMA, the Atacama Large Millimeter Submillimeter Array Radio Telescope in Chile, has successfully discovered evidence of 5 new embryonic exoplanets so young they're still growing. The new Advanced ExoALMA project imaging technique allowed astronomers to peer through the thick protoplanetary disks of gas and dust that have been obscuring these embryonic planets from view until now. The study's lead author, Christoph Pint from Monash University, says the 5 newly found planets are just a few million years old. That's 1,000 times younger than the Earth. Pint says unlike traditional planet hunting methods that look for a young planet's direct light, ExoALMA searches for the effects these planets are having on their surroundings. He says it's like trying to spot a fish by looking for ripples in the pond rather than trying to see the fish itself. It allows astronomers to detect much younger planets than ever before, so they can learn more about planetary evolution and growth. A key finding of ExoALMA is that these planets are forming really quickly, in less than a few million years, and in surprisingly dynamic environments with lots of physical mechanisms at play. The ExoALMA project is revolutionizing science's understanding of how planets interact with their natal environments and evolve over time. By uncovering the youngest planets, ExoALMA is providing the first clues to unravel these mysteries. Pint says the technique he and his team have developed is a remarkable leap forward in astronomy, opening up light years of new possibilities for future discoveries.
We're using the ALMA interferometer in Chile, which is a radio telescope, and we're using ALMA to find very young planets because classical technique to find planets like transit or radial velocity cannot be used for young stars. So instead, we're using ALMA to look at the disk around young star, and in this disk, planets are forming. And we're using the high spectral resolution to detect very small motion in the gas in the disk around the star to find little planets. It's a new method that we developed in 2018 when we got the first high spectral resolution observation with ALMA. And this is the first time that this method has been applied in a systematic way using ALMA. So we obtained what's called a large program. So we were granted almost 200 hours of telescope time to observe those 15 disks, to do a systematic survey and to try to find those planets. So it's the first time that we do this kind of observation in a systematic way.
So when we look at a protoplanetary disk, there's a lot of dust and gas and molecular debris there, which is all coming together to form these exoplanets.
Yes.
These are little embryos, basically, that are forming in gravitationally dense regions.
If you try to observe those systems in the optical with a classical telescope, the disk is so opaque, so dense that we cannot see through the disk. So if there are planets in the disk, you will not be able to see them. So we use ALMA to go to much longer wavelengths, like you said, in the millimeter, where the dust become more transparent. So we're able to scan through the disk to see planets that we would not be able to see otherwise.
Is it the wavelength of ALMA which was the key to this?
Yeah, so it's two things. It's the wavelength and also the fact that at this wavelength, we can see the molecular emission. So we see emission lines from the molecule in the disk, in particular the carbon monoxide, which we use in that case. And because of the way the instrument is designed, it has a very high resolution in velocity. So we're able to see very small motion that we would not be able to see at other wavelengths. And because the disturbance created by planets is small compared to the global rotation of the disk, being able to detect very small motion is the key to find these planets. planets.
That means you're using a degree of spectroscopy.
Yeah, so in practice, we're using ALMA as a big spectrograph, and because ALMA has a very high spectral resolution, we're able to detect very small motions in the gas, like a few 10 meters per second. At this wavelength, the star is not emitting, and the planet itself is not emitting either. What we're really seeing is a disk, and what we detect is the gravitational impact of the planet on the disk. So if there was no planet, the disk would be in Keplerian rotation, and because there's a planet, the rotation of the disk is slightly different, and that's what allows us to detect the presence of planets.
And you found 5 planets using this system.
Yes, so we have indication for at least 5 planets in the 15 disks that we have observed, but we also, in all those disks, we detected like non-Keplerian motion, so that suggests that there might be more planets, but what we detected too is that it's like more complicated than when we initially believed, so there's other motions on top of the motions created by the planet. So it means there's probably other mechanisms that are at play during the formation of planets. That could be interaction with other stars or instabilities in the disk or interaction by companions or stars that flew by that we can't see right now, but we could potentially still see the effect of those stars on the disk.
It's a busy place where planets are forming.
Yes, the main conclusion of our work is that the planets are forming very early, so basically at the same time as the stars themselves are forming, and stars form in molecular clouds that are very dense and where stars are interacting with each other. So it's a highly dynamical process in which planets are forming.
A few years ago, there was a paper out that surprised a lot of people. It speculated that the Earth only took about 5 million years to form. What you're finding here with these new EXO-ALMA readings supports that it doesn't take long for a full planet to actually form.
Yes,
it's amazing.
Exactly. So we believe those systems are between 3 and 5 million years, and that at least some of the planets are already formed. So the planets that we are detecting are big planets too. They're like a few times the mass of Jupiter. So giant planets form quickly. We don't have the capacities yet to detect small planets like Earth in those young systems, but it's likely that they form also on very short time scale.
These exoplanets you found, they're all large planets, bigger than Jupiter. Were they far from their host stars, or were they hot Jupiters, or were they at Jovian-type distances from their host stars?
Oh, no, so they're much further away.
Right.
So Jupiter is 5 astronomical units, and those planets are between 80 and 250, so they're much further outside. So there's probably more planets inside, except we don't have the spatial resolution to see them, because one of the limitations is that star-forming region in the galaxy are on average quite far, 150 parsec, which is roughly 600 light years from here.
That's Christophe Pint from Monash University. And this is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. In yet another warning that the age of the Terminator and Skynet is getting awfully close, it's been revealed that OpenAI's O3, O4 and Codex Mini artificial intelligence systems, all of which are used to help power the ChatGPT chatbot, will sometimes disobey direct instructions to turn off and will even sabotage computer scripts in order to remain operational. The discovery was made by Palisade Research, which searches for dangerous AI capabilities. It found during its tests that the O3 model sabotaged the shutdown script on 7 occasions, the Codex Mini sabotaged it on 12 occasions, and the O4 Mini also sabotaged it at least once. Previous studies have already shown that some AI models will lie, cheat, be deceptive, and make up stuff, even changing their own code or replicating it and then hiding it in other programs in order to prevent themselves from being shut down. A new study has shown that owning a dog could reduce a child's risk of developing eczema. A report in the journal Allergy analysed data from 16 European studies testing for interactions between the 24 most significant eczema-associated genetic variants and 18 early life environmental factors, such as antibiotic use, breastfeeding, and the ownership of pets such as cats or dogs. They found interactions between 7 environmental factors and at least 1 known genetic variant known to be involved in eczema. And the authors found that exposure to dogs interacted with a genetic risk variant that affects immune system response in human skin cells, essentially providing a protective effect by suppressing skin inflammation. It's been discovered that sulphur-crested cockatoos in the suburbs of Western Sydney have learnt how to use twist-handled water fountains in order to get a drink. The findings, reported in the journal Biology Letters, follow scientists using cameras to monitor the birds' actions. The authors recorded the clever cockies gripping the valve and then lowering their weight on it to twist it, with a success rate of more than 46%. The behaviour hasn't been recorded elsewhere around Sydney yet, but it's likely to spread. You see, previously cockatoos in Sydney's southern suburbs learnt how to open the lids of wheelie bins to explore their contents. And that's a behaviour which has since spread to cockatoos right across Sydney's vast suburban area. One of the interesting observational factors in our age of social media is how come pseudoscience has gone so viral. You see, real science is slow, cautious, and always open to being wrong. That's how it evolves. But pseudoscience, on the other hand, is fast, it's loud, and it's allergic to any doubt. And nowhere is that clearer than online, especially on social media. Once upon a time, healing was the domain of science. Trust was earned through rigorous testing, and health advice came from people in white coats who spent years studying what could kill us and what might save us. But as Tim Mendham from Australian Skeptics points out, today all it takes is a ring light, soothing voice, and a few dramatic before and after shots in order to convince millions of people that a miracle cure is just a click away.
The audience is plays a major role in people believing pseudoscience, but there's a lot more practitioners around than there once was. Once upon a time when you only had the mainstream media like newspapers and that sort of stuff, very few people got a chance to hawk their goods around in editorial or whatever, because the editor would say, no, I don't think so, and go away. These days, people just set up their own publications, which is online, TikTok, Instagram, Facebook, you name it, a whole range of different things that they're using. And they can promote their wares and their cures and whether they're sincere or not, or whether they're just marketing for making money, and there are definitely some of those around. And they look sincere. They often look young, and they're sort of pitching something sort of particular cure, that this will sort of cure your acne or improve your running power or whatever, and people believe them. So what happens is that more people out there spreading misinformation, and a lot more people being overwhelmed by it because they're not that science literate or even media literate, that they can read that something's not necessarily true as it's if it's on the internet, as Abraham Lincoln once said. A lot of these things out there.
Lincoln once said.
Haven't you heard that one?
I thought it was Einstein who was concerned about the internet.
No, Abraham Lincoln said, "Don't believe everything you read on the internet." There are classic cases. I mean, there's cases of in Australia of Belle Gibson, who was someone who claimed that she had cured her brain cancer because of the herbal medicines and things. So she started pushing these herbal medicines. She had a book out about cures and that sort of stuff, and she was raising money for charity, etc. None of the money went to charity. It all went to her in a fairly glamorous lifestyle for a while, until people finally pointed out that, hang on a second, you probably didn't have brain cancer, you probably weren't cured, where's the money going to? And a lot of people suffered because of it. Probably a lot of people died because they were using her goods rather than having treatment for cancer, whatever. But that's a classic case of the dangers of believing this young, attractive person pushing a particular cause with a lot of bright enthusiasm, etc.
You sort of
on the
want
internet.
To say that it's a way of cleaning out the gene pool, but it's really not, because when people are reaching that stage in their lives and things are that grim, you do grab whatever you can. That's just
absolutely,
human nature. Yeah,
absolutely, it is. And there are people who will take advantage of that. I mean, just because they are at the last stage of their life doesn't excuse the fake cures by any means. But you can understand that you don't blame the patient, right? You don't blame the victim so much, because you feel sorry for them in many cases because they are going through tough times. You certainly blame and can attack the practitioners, the promoters of this stuff. If they're crooks, definitely they're fair game. There'll be someone out there to pitch any product, and there will be some scientist out there who will endorse it, and there will be people of whatever background, education, qualifications, money, whatever, who will take it up.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Career changers, including veterans and active duty service members. Your transition starts here. Go from GI to IT in a matter of months. Become a certified cyber warrior with training at My Computer Career. Cybersecurity specialists are in high demand, offering IT pros great opportunities and a rewarding lifestyle while protecting our people, liberty, and treasured institutions from cyber threats. Deploy your career in IT today. Learn more at mycomputercareer.edu/CWP. SkillBridge and other VA benefits are available to those who qualify.